GCSE Astronomy Topic 10, Inside the Sun. Now, there are three inner layers. We talked about the outer layers. There are three inner layers. Working our way inwards, there's the convection zone, the radiative zone, and the core. Now, the visible surface of the sun, if you look at it, it looks like a bubbling stew. There's all kinds of material rising up to the surface and then sinking back down again. From GCSE physics, you should know about convection currents. Convection is like hot fluids rise and cold fluids sink, and this is what's happening in the convection zone. Hot stuff bubbling up to the top and then sinking down again. Hotter stuff rises, cooler stuff sinks, and this is how energy works its way to the surface. It's all about energy working its way to the surface. And here's a very nice image of the surface of the sun taken by a telescope in Hawaii. In the radiative zone, the energy is carried by photons, high energy photons, packets of energy in the form of electromagnetic radiation. And these photons are produced in the core and they work their way to the surface through the radiative zone to the convection zone. Okay? Interestingly, the photons don't travel, even though photons travel at 3 times 10 to the 8 meters per second, very, very fast, at least in a vacuum. These photons take more than 1 million years to get to the surface because they're absorbed and re-emitted many, many times on their journey. The core of the sun is where the interesting stuff happens. This is where nuclear fusion happens. Now, the key things to remember about nuclear fusion. Fusion means joining together. Hydrogen nuclei fuse together to form helium nuclei. The chain of events is called the proton-proton chain, which I'm not going to explain to you because you don't need to know about neutrinos and things. Basically, you start with protons, which are your hydrogen atoms, and you end up with helium nuclei. Okay, so hydrogen is changing into helium. Yeah, hydrogen atoms are fusing together to form helium. This can only happen at very, very high temperatures. The temperature of the core is about 15 million degrees centigrade. To get these hydrogen atoms to fuse together, they need to bang into each other very, very hard. This is why it's been so difficult to get nuclear fusion happening on Earth. If we could do that, we'd have limitless energy. If we could do it on an industrial scale, rather. Okay? Another important point is, where does this energy come from? Well, it's actually mass being converted into energy. I'm sure you've heard of E equals mc squared, Einstein's equation, and this represents energy coming from mass changing into energy, where E is the energy, m is mass, c is the speed of light. E equals mc squared. This has been happening in the sun for about 5 billion years, and it will carry on happening in the sun for about another 5 billion years until the hydrogen starts to run out. And then interesting things will happen, which we talk about in another topic.